Alright, there are two types of special right triangles where we can use some really quick proportions as shortcuts to find the missing sides. So one of those ways is a 45-45-90 triangle. The relationship for the sides is 1 to 1 to square root of 2. And then for a 30-60-90 triangle, the relationship is 1 to square root of 3 to 2. And we're going to use proportions to solve. And that's really the key here. Alright, example 1. If you could draw that with me, we have a right triangle, and it's isosceles. And for an isosceles right triangle, I already know that I have a right angle of 90, and I know the whole triangle adds up to 180 degrees. So if I just do 180 minus 90, then I have 90 degrees left over for these two angles. Well, I know that they're going to be identical because this is an isosceles right triangle, so I know those are going to be 45. So I'm going to go ahead and fill that in. This angle is 45, this angle is 45. Alright, so it says to find x and y. Well, y is pretty simple because of these hash marks. That hash mark there and this hash mark here tells me they're the same, so I know that y equals 3. And to find x, yes, we could use Pythagorean theorem, but let's use it using our proportions, or special right triangles. So I'm going to write, I know the 45-degree angle right here goes with this side 3. So I'm looking at the sides that are opposite of my angles. So I'm going to come over here, I'm going to write 45 down, because I know that one. And I need to find out x, which is my 90-degree angle. Remember, these are degrees. So in other words, I know the 45, and I need to know the 90. So I'm going to write, for my 45, it's 3. Actually, I can back up. I'm going to use my relationship first for 45-90. Look up here at our chart. 45 gets a 1 relationship, 90 gets a square root of 2. So I'm going to go ahead and set up my proportion that way. So 1 over square root of 2. And now I'm going to fill in. 45 gets a 3, then 90 gets an x. And now it's as simple as, well, actually I could cross multiply, but there's a much quicker way here. How do you get from 1 to 3? You just multiply by 3. So these are equivalent fractions. So just do times 3 times 3, and that's our shortcut. So it's square root of 2 times 3 is x, and I can write that like this. Alright, next up we're going to do a 30-60-90. Alright, jot this figure down with me. We have a 30, 90, and then I don't know the other angle, but it's pretty easy to find, right? I have 90 plus 30, that's 120, and I just do 180 minus 120, and sure enough, this is a special triangle because it's a 30-60-90. So I'm going to fill that one in. It has 60 degrees. Alright, so I want to find x and y, so I'm going to set up a proportion, and I get to pick which one I want to do first, but this is crucial here. A known measurement must be part of your proportion. So you can't just go randomly selecting sides, like I can't choose x and y as part of my proportion. I need to have one known value, for instance the 12. So what's the 12? What does it go with? Look at the angle opposite. 90. So I have to use 90 for part of my proportion. So I'm going to write 90 down. Then I get to pick. I'm going to use 30 for my other one. I could have chosen 60. And then if you recall, I'm just going to jot down what we wrote above. A 30, 60, 90 has a relationship of 1 to square root of 3 to 2 for the sides. So I'll fill that in here. What goes with 90? 90 has a 2. So I'm going to write that ratio right there. So 90 gets 2. And I'm using a 30, so 30 gets a 1. So that means that the 90 is actually double the 30. Alright, and I'm going to go ahead and plug in for my 90. Look at my actual triangle, and opposite the 90 is the 12. So I'm going to plug in a 12 over here on top in the 90 spot. And then over here for my 30 degree angle, what goes with 30? X. Because x is opposite 30. And now, again, I would cross multiply, but this one's much easier because it's just a double relationship. So how do you get from 2 to 12? And the answer is you multiply by 6. So I just do times 6 times 6, and 1 times 6 gives me x equals 6. All right, now we only have one down. We still have one more to go. And I'm going to fill that x equals 6 in right here. I'm going to circle it to show that I just solved for it. So now I can use either of my two known measurements for my next proportion. Doesn't matter which one. So let's say that I wanted to use the 6 now. The 6 goes with the 30, so I could use 30 degrees over, and then which one do I have to use for y? Y is opposite what? The 60 degree angle. So I'm going to use 30 over 60 for my proportion. And now, what's my relationship with 30? 30 gets a 1, 60 gets a square root of 3. So I'm going to write 1 over square root of 3 equals, and then now look at your actual triangle. What goes with 30? 30 goes with 6. So 6 goes on top. And then now we have a 60 degrees on bottom, so 60 goes with y. Always look at the opposite side of the angle. And now to solve, do we see any shortcuts here? Well, how do you get from 1 to 6? You just multiply by 6. So yeah, there's another shortcut here too, isn't there? Just times 6 times 6, and we would get 6 square root of 3. And you can type that in to get the decimal value. The other way to do it, of course, is to cross multiply. I'm going to show one way, just so you can see it. And I call that bottom top drop. You do the bottom number times the top number and drop it down. Bottom number times the top number and drop it down. So just to show that, because you will have a couple where you might need to solve that way. So that would be 6 square root of 3 equals y. And actually that was just as quick as the other way. Now when would this have been different? Well, if I would have had a number that wouldn't have gone into 6, like maybe a 5 right there, then I would have had a 5y and I would have had to divide here. So I just wanted to make sure you were aware we could have one where there's a couple steps involved. Alright, let's apply what we learned. Let's say if you wanted to find the length of a square's diagonal if the perimeter of the square is 32 inches. Well, when in doubt, draw it out. And I live by this motto when I solve math problems. So if I can't visualize it, I'm going to definitely draw a picture so I can. So I'm going to draw a square, because it says square. And what do I know about a square? All the sides are the same. And I'm given the perimeter here, and perimeter means if I add up all the sides, well, how many sides do I have? 4. So I just do 32 divided by 4 would give me what each side is. So each side equals 8. So I can fill that in on my picture. So this is 8 inches, 8 inches, 8 inches, 8 inches. That makes this a lot easier now. And now it just says the length of the diagonal. So I'm going to draw a diagonal. I can draw either one I want. I'm going to draw that one. And I also know a square has a right angle to it. So suddenly I have a right triangle. And what kind, you ask? 45, 45, 90, because it's isosceles. Right, so if you put a diagonal through a square, you're always going to get an isosceles right triangle or a 45, 45, 90 right triangle. Okay, so, and I want to find this diagonal, so I'm going to call the diagonal x. So I'm going to write 45 over 90, and why am I doing that? Because I know my 45, the side that goes with the 45 is 8. I don't know the 90, which is my x. So I'm going to write 45, I'm going to write my ratio. Do you remember the ratios? I'll write those down again. 45, 45, 90. Right triangles have a relationship of 1 to 1 to square root of 2. So I'm going to fill in a 1 here and a square root of 2 there equals, and now I'm going to look at my actual picture, and what's in my picture there? I have a 8 for 45, so 8 is opposite the 45. I'm going to put it on top. And then I have a, opposite the 90, I have an x. And again, I can cross multiply or I can do the shortcut. I'm just going to show it with the cross multiplying. So square root of 2 times 8 is 8 square root of 2. X times 1 is x. And that's it. And I could do 8 square root of 2 in my calculator. That just means 8 times the square root of 2. And I want to leave you with one final summation here. Remember, the first ratio in the proportion, so like up here, the 1 square root of 2, has a relationship of the sides. So for example, that was a 1 to square root of 2 relationship. Now the second ratio has the actual side measurement. So there you have to look at the diagram. So the 45 gets a 45 gets an 8, and the 90 gets an x. And that's what goes here. In case you weren't sure, the sides opposite of the angles is what we look for. The sides opposite of the angles. So for instance, 45, the side opposite of that is 8. 45, the side opposite is 8. 90, the side opposite of that is x. All right, that sums it up.